Hi, my name is Derek Reynolds, and this is the explanation of how lift is produced and causes an airplane wing to fly. This course is Aviation 225 and with Professor Peter Spar. And I will be explaining to you just how airplanes generate lift over the next few minutes. First, we will explore a couple of things like Newton's three laws of motion, the Magnus effect, Bernoulli's principles of differential pressure, and airfoil design, all which come together to generate lift so an airplane can fly. First, we will be going over the Newton's three laws of motion and basically the principles of flight, which I have right here. I don't know if you can see this. Okay, so basically these are the three laws of Newton's laws of motion, and the first one is every object persists in a state of rest or motion in a straight line unless it is compelled to change that state by forces impressed on it. Basically, this is the law of inertia. Basically, if you put an object into motion, it will stay in motion unless acted on by an external force. The second law of motion is force is equal to the change in momentum per change in time. For a constant mass, force equals mass times acceleration. And basically, this is the law that counteracts inertia. Now, Newton's third law states for every action, there is an equal and opposite reaction. So basically, how this works in an airplane is that the propeller will generate lift. Propellers actually do generate lift. That's how they create thrust, and it pushes the air back. When it pushes the air back, it propels the aircraft forward. So there's an equal and opposite reaction. The next is Bernoulli's principle. Bernoulli's principle of difference in pressure explained how the pressure of a moving fluid, liquid or gas, varies with its speed of motion. Bernoulli's principle states that the velocity of a moving fluid, liquid, or gas increases the pressure within the fluid decreases. Basically, the best way to visually explain Bernoulli's principle is a Venturi tube. So basically what happens is that if you have air entering the Venturi, and they are both equal in velocity and pressure, that once they reach the center or the focal point, the pressure would have decreased and the velocity has increased. And then once it exits, that the pressure and velocity now become equal and they are back to the same. So how is this applied? How is these principles now applied to an airfoil to generate lift? So basically, the way an airfoil is shaped is basically how well it will produce lift. You want basically a flat bottom, so that way the pressure and velocity on the downward edge of the airfoil is pretty much equal and not really doing much. On the upper portion of the airfoil is basically, this is on a molecular scale, it's a pretty violent process in which air is hitting the airfoil at a certain angle, creating an area of lower pressure and high velocity. This low pressure is what generates lift. As the airfoil moves faster and faster through the air, the area of low pressure becomes lower and lower and lower, basically, so now you, for every action, there's an opposite and equal reaction. So if the area of low pressure is getting so low that it actually will generate lift and take the airplane off the ground. There are many different types of shapes of airfoils that will produce different types of lift, all pretty much desired by the person flying the aircraft. Now, what also determines either a greater force or lesser force of lift is the angle of attack. The angle of attack is a camber line running, basically a straight line running through the center of the airfoil at a point in which, relative to the wind. So and each point where lift is generated is called a center of pressure. The center of pressure is basically what lifts the airfoil up into the wing, up into the air. And depending on if you have a negative angle of attack, well, you're creating a higher pressure down below a lower pressure down below the wing, and a reduced pressure above the wing, which causes the airfoil to descend. If the airfoil wants to ascend, well, depending on your angle of attack, you have 4 degrees or 10 degrees. Each one, the 4 degrees gives you a little bit of ascent, and the 10 degrees obviously would be more of a steep ascent, generating more lift. And that, ladies and gentlemen, is basically how lift is generated by an airfoil. Thank you.